In this lesson, I wanted to talk about multiple variable equations. We've been doing some equations so far, but all of those ones that we've been doing are called single variable equations because they only have one thing that changes with the term. So usually our single variable, or we've represented it very different ways, but more recently a lot of our single variables have been represented by the letter n. For example, we could say 3n plus 2. In this case, n is our variable because it's the thing that is changing as we increase our term number and things like that. So every time the 3 and the 2, which is our multiplier and our constant, they remain the same. This one is variable, it changes. So let's look at our problem that we have here. This is a problem that requires two different variables. We have 15 coins, and those coins are made up of both quarters and dollars. Dollars are loonies in Canada, and quarters. So we know that those 15 coins together give us a total amount of money of $6.75. How are we going to represent this? So we do need two variables this time, so we can't use n. I find it easier to use letters that go along with what we're looking for. So if I use Q for quarters and D for dollars, we know that if I add all of the quarters together, not the value of them, just the actual coins together, with all the dollars, that we're going to have a grand total of 15 coins. So it doesn't matter what these are worth at the moment, but we just know if I add however many quarters we have with however many dollars we have, or loonies, then that's going to give us our total number of coins. So that's going to be 15. What else do we know? Well, we know that a quarter is worth 25 cents. Now, I could write that as 25 cents if I wanted everything to be done in cents, but I'm going to try to put everything in dollars for this example. So instead of putting 25, I'm going to put 0.25 because 0.25 in dollars is 25 cents basically. Same thing. And I'm going to times that by Q because the total number of quarters that we have, if I multiply that by 25 cents, that'll give me a value of money. Now if I add that to our dollars, so I'll put $1, 1.00 times D. So now this time, just sort of ignoring the quarters for right now, if I just have $1 times the total number of dollars that we have, that'll tell me the value of all the dollar coins that we have. Now, if I'm adding these two together, so the total value of our quarters and the total value of our dollars, we know that that's going to give us $6.75. So we've created two equations that can allow us to figure out how much money we have. Now, at the level of mathematics that we've learned about, there's probably a few different strategies that we can use, but pretty much trial and error is the main way that we're going to do this. However, there's a more efficient way to think about trial and error, and that's to create a chart. So normally we've created a t-chart. This time we actually need 3 columns, so it's a bit of a modified t-chart. It's got an extra column in it. And in those columns, we need to have our quarters, we need to have our dollars, or loonies, and then the total value of our money. So I'm just going to call that V for total value. Now, what I find is the easiest way to start with is to just imagine that all of them were quarters or all of them were dollars. So if we have 15 coins and I have 15 quarters, that means that none of them can be dollars because I've already used up my 15 coins on quarters. So I've got 15 times 0.25 plus nothing because there's no dollars here is going to give me a value. So 15 times 0.25 we find is 3.75 or $3.75. So that's obviously lower than what we're looking for. We're looking for $6.75. Now, what if they were all dollars? Well, if they were all dollars, then there couldn't be any quarters. So we'd have $15, and 15 times a dollar is $15. Okay, so we realize the more dollar coins we have, the bigger this number is going to get, and the more quarters we have, the smaller this number is going to get. So when we look at this, we can see it's probably closer to the to having a larger number of quarters than it is having a larger number of dollars. So we can pick a random number. I'm going to say what happens if we have 10, just because 10 is a nice easy number. If we have 10 quarters, well, how many dollars would we have? We'd be left with 5, because that would give us our 10 plus 5 is 15. Now, now we have to do this mathematics. So 0.25 times 10 is $2.50, or 2.50. And 5 times $1 is 5. So $2.50 plus $5 is $7.50. So as we can see, that number is still higher than what we're looking for. So we want to get closer, or we need to get lower down, and that means having more quarters. So 10 is not enough quarters. We need more quarters than that. What happens if we try 12? Well, if we had 12, that would mean we'd only be able to have $3, and that would give us, so 12 times 0.25 would give us $3. And then 3 times $1 would also give us $3, so $3 plus $3 is $6. So we're a little bit high here and a little bit low here, but you can tell we're getting close, and I'm pretty sure you can now guess what our actual number is that we're going for. So between 10 and 11, 10 and 12, the only number we have is 11. So if we have 11 quarters, that means we're going to have $4. And if I did 11 times 0.25, that's going to give me $2.75. And if I do 4 times $1, that's $4. So $2.75 plus $4 is $6.75. So we've now found the number that we're looking for. And you can go back and check this and make sure that everything makes sense. But we have determined that if we had 11 times 0.25, 4 times $1, that those will add up to give us $6.75, and that's what we're looking for. So you can use strategies like this to help you solve multiple variable equations. We could have done it with more coins. We could have included dimes in here, or toonies, or pennies, or nickels, whatever we wanted, and it would just give us more variables. So we could have more than 2 variables in an equation. It would still work. We could still use this same strategy, but obviously it gets a little bit more complex and a little bit more difficult to make your guesses. So I hope you found this useful.